Okay, great. So we wanted to have this meeting partly to help generate some topics and then partly to help generate some ideas of folks want to see come in the coming semester, and then beyond that. So in general, I think our format will be like, we'll ask around for topics that people want to see. And if there's any topics that you want to see like a series about, that would be especially interesting to us. And then we'll call for nominations for particular folks at the end, if that sounds good. If there's anything else that folks want to discuss, we can do that as well. Okay, cool. So then let's turn to topics or series that you'd be interested in. Are there any specific ones that you want to see? We still have a few slots this semester, but think about beyond that.
One topic that I had in mind, I talked with Helen about, was something on the horizon, and maybe even a kind of joint session with the colloquium where we would have Eric Curiel on philosophy of the horizon, Ramesh on observation of the horizon, and Netta Engelhardt on the mathematics or the mathematical physics of the horizon, a kind of a panel discussion that might go with 20, 25-minute presentations combined with discussion and interaction. And so that, I think Eric is coming in February or so. Anyway, just an idea.
I will also throw in, so Jacob sent me his thoughts via email. And he was also in favor of a seminar style rather than a particular like one-off lectures. And his topic that he wanted to see covered is how probability meshes with GR. And then he recommended a bunch of speakers, but they're all speakers mostly in the UK. So they would have to zoom in.
Another suggestion that I have is on dark matter. What is the history of dark matter? What is the sorts of mathematics or models that people use to describe dark matter from the cosmology of like observational astronomy, astrophysics side, as well as from the mathematical cosmology side. So like, there are different ways. Like one is to introduce some sort of matter model. One is to introduce modifications to the action of the theory itself. So it would be interesting to see both sides and have a discussion on that. I think that'd be good to clarify various positions in the field. So,
if Niels were here.
and also Yako. So
yeah. But we can get them in.
Yeah, but Prashant, dark matter is not necessarily black holes, unless you think it is, mini black holes. So, I mean, I'll defer to Peter on this, but we may want to keep to topics that really, kind of touch on the key aspects of black holes.
I think that's right, Ramesh. But perhaps was the proposal that we would talk about black holes as dark matter, as a candidate for dark matter? I know that our Dean of Sciences, Chris Stubbs, is extremely interested in that. Has been working on that area. But I agree, Ramesh, if it's just dark matter for dark matter's sake or for the explanation of galactic dynamics or something like that, I'm not so interested for this context. But if it's black holes as dark matter, then suddenly it becomes relevant. Do you agree with that, Ramesh?
Yeah, that was really the gist of what I was saying. We should try and keep the black hole connection as much as possible. And, there is a small group of people who think it's viable. for dark matter to be made of little black holes. We've even had some colloquia on that, I believe. But that's a small subfield. I think Prashant was more interested in basically dark matter as a whole, without even worrying about what it's made of and what its equation of state is. How do we set it up? Is that right, Prashant?
Yeah, I was thinking a bit more broadly, but I understand.
Is that really a hard constraint though? Isn't it interesting and fun to hear about some other physics sometimes? Or is that, I don't want to yuck anyone's yum, but that is also, but also, sorry, I just entered the room. I'm not sure what the topic is, but like in general, I find seminars and colloquia should also broaden a physicist's mind and a philosopher's mind and an astrophysicist's mind, maybe. So if there's any remote link, is that not enough?
Maybe we should think about it a little more on this.
I do have a topic that I think is sort of interesting. I think like, especially since all the theory around, especially in GR and black holes, it's develops over many decades. There are sort of ideas that manifest early on, and then they get communicated to the general public as an explanation for how things work. And then of course, our understanding of those things improve over time, but then those explanations kind of stick around. I don't know how one would do this, but I think it'd be kind of interesting to discuss those like these common misconceptions that have stuck around and why they've stuck around and where they came from.
There's something in the chat.
Oh. Okay, general effective field theory and Kerr-Newman black holes, the firewall paradox and complexity, and error correcting codes, gravitational waves, and the Kerr-Newman black holes, reliability of observations of the NG EHT. Okay, cool. I guess I'll also say for the folks that came in the middle of this conversation, we were just talking about future topics that we might be interested in seeing as part of this group. And also feel free to voice if you would rather see a topic as a one-off or like a seminar style, a few lectures about it or something like that.
Sorry, have you already discussed your idea of the, what was it, the modified gravity?
Yeah, we have.
Okay, great.
Yeah, we wanted a closer connection. Some of us wanted a closer connection with black holes, and so we'll think about it. Okay. There's a common ground that we have.
And about connecting it to, right, because the seminar is also the foundations focus group of the HPC of the NGHT. So how many people are in the fundamental physics working group of the NGHT, and how many people are in the EHT fundamental physics working group?
I think the fundamental physics working group in the NGHT is slightly bigger because it's an open collaboration still, so it's slightly bigger.
What's that?
So it hasn't met in a while. When it was meeting, they were like order 20 or 40 or something at the very beginning.
Because I guess it would be good to the extent that this is not just the old foundation seminar, but also HPC to invite speakers from each team or NGHT physicists from those fields and talk maybe more directly and maybe even kind of write a foundations NGHT HPC paper together at some point. But Gali's last topic maybe fits better with the AIV focus group or not, depending on what means exactly. Reliability of observations.
Gali, would you like to expand on that? I guess either through the chat or through video.
Yeah, I mean, according to Nancy Cartwright, have you read her book with ANSI Nancy Cartwright, she defines reliability. And I mean, according to Cartwright's definition, if you read her book and Cartwright's definition, the philosophical definition of reliability. So I would like to hear, maybe Nancy can give a lecture about it.
I think to the extent that is like robustness, that's kind of the core topic of the AIP focus group. So
Yeah, right. But this is another topic.
but the other topics seem very appropriate.
But I
Yeah.
think on reliability, we've had like colloquia, for example, even by Helen, on how to compare between simulations on dark matter. So I think it could be relevant here as well.
Reliability is, instead of focusing on truth, you ask about the reliability of instruments, theories, and whatever concerns experiments. You have models and theories and instruments and other things that you take into consideration when you do experiments. So the focus is on reliability rather than on truth. And when you ask about the reliability, then afterwards you also arrive at the truth of the experiment, but you first focus on the reliability of all the ingredients of the experiment. That's Cartwright's main, but this is a simplistic explanation. Of course, Cartwright's theory is much more complicated. I gave a simplistic explanation. I'm sorry. But this topic is really interesting.
Another thing that I think is kind of interesting is this idea of like GR as a gauge theory. I think it's sort of interesting within the context of, or at least the way how I think about this is interesting within the context of, like, if Einstein had not come up with GR, at least I always imagine that the field theorists would have eventually come up with it. And I think the way they would have formulated it is through the lens of a gauge theory. And I think the way how you think about the problem as a gauge theory versus the geometric point of view that Einstein picks sort of leads you to ask different questions. Or I think it's sort of interesting to think about how the way how you think about the problem for those two different lenses differ.
So I have a suggestion. So back maybe 6-7 years ago, when we first started this philosophy discussion, and Eric was our master of ceremonies, I remember being absolutely, gobsmacked by the number of unsolved problems or paradoxes or things that just don't hang together. So, Eric, I remember, I think it was Ehrman's book, Gerosch's review, and your review primarily, of course. A lot of it was Penrose diagram based, but pretty much everywhere there were open questions. What do we know and what can we prove and what's uncertain? I remember kind of late in the game, there was this whole business about black hole evaporation. Exactly what happens when the black hole evaporates? That corner point in the singularity, what does the Penrose diagram do there? Is it analytic? Can it be expressed, etc.? There were a whole lot of stuff. Of course, it's 6 years ago, or was it 7 years ago? I've forgotten a lot of it. Most of the people here didn't even hear the original version. I think it would be great to revisit some of those topics, not a whole semester like you did last time. You pick and choose, but some small number of, I would say open questions with enough background. You be the leader, and it'll be good for all of us to listen to this. Peter will remember, of course, because this was a real start with a bang. I think this really got its character. This whole seminar series got its character from the way Eric ran it the first time around. So anyway, that's a suggestion. A little bit selfish. I just want to revisit something that I was very excited about many years ago. But maybe Peter should comment on this.
Yeah, I think looking at open questions would be very good. And I think we might do well to go back to the specific example that you gave of Hawking radiation. If there are all these claims that, what relationship the UNRU analysis has to Hawking radiation, and, there are different claims about the status of Hawking radiation. I'd love to hear Andy Strominger talk about that, or Andy in conversation with someone else, or get Bill Unruh to come and, even if it was virtually, to talk about some of those things. I think it could be fascinating. So yes, to open questions. I think if we can pull some of that in, it would be good. On a previous comment, I think it was Prashant, sorry, I'm only on audio, about the gauge versus, or the particle versus geometrical approach. The beginning of Steve Weinberg's book on gravitation starts by saying, if Einstein hadn't invented general relativity, it would have simply emerged in a natural way from a spin to mass zero, graviton analysis. And that's a long tradition that comes out of Feynman and others. Dave Kaiser at MIT has written about that history. And that might be an interesting, if we wanted to look at different ways that these things were formulated and what is propitious for understanding in different ways. If we had a panel on that or something like that, I mean, Dave Kaiser would be good to include.
I also have a personal sort of suggestion, to understand better the initial value problem and also Cauchy horizons. So when we say, naked singularities break down predictability, what exactly do we mean? Like, in what sense are they breaking down predictability? And it would be good to have that looked at a bit more carefully and closely, I think, because different people mean different things. Like, for example, geodesics outside of the singularity itself, all normally, etc. At the singularity, obviously things break down, but what exactly happens? What happens in a collapse to a naked singularity? I think that would be interesting to look at as well, if there is interest.
That sounds great.
Okay.
Also ties nicely to the lectures that we have at the end of last semester.
Yeah, exactly.
Cool.
Yeah.
Can I say something about black hole evaporation? So I think it would be a good topic, but maybe instead of asking Andy or Bill, we could ask someone that actually works on it now, like Neda, who's part of this collaboration, or other people in the field that are working on it. Actually, that would be good.
I definitely like to get Neda involved. I talked to Neda about the horizon problem and how it's conceived differently in the different branches of BHI. So that was one of the motivations for my thinking that the horizon would help.
Oh yeah.
Sorry. I'm in Penn Station waiting for my train. Sorry.
I got you down, Eric, as a panelist. Thanks.
Eric wrote in the chat.
Eric, do you have other suggestions as well, in addition to this? Regarding either your leading a discussion on open fundamental questions or just other topics or suggestions as well.
So, Prashant, that was directed at me.
Yes, yeah.
So, well, I think I really like Ramesh's idea, because I do think that the number of open problems is large and surprising if one hasn't really been exposed to them or thought about them before. I don't think I would necessarily have be the person to lead that discussion or seminar. If no one else wanted to, or if no one else is available, I would be happy to do it. But since I did, as Ramesh remarked, since I did lead some seminars on that several years ago already, I would be very curious to hear what other people thought about what important open problems are and how they may or may not be addressed.
Eric, you could, leading doesn't have to mean running that particular seminar. Leading could be introducing the topic and then wrangling, figuring out with us who might be good for a series of 3 such occasions. So I'm just saying, I'm not, yeah. It doesn't have to be you writing 3 lectures.
I would be very happy to do that.
I could help you think about that if you like. We could brainstorm about who to ask. I know I'm not a philosopher, so you would have to teach me a bit about that, but I know something about black hole evaporation.
Has anyone mentioned Alex Manti as potential speaker, or is he already?
No.
So I think Eric, he is or was your student, right? And he just published a chapter in his philosophy of astrophysics volume on, I think, black holes and
yes, that's right.
So he could maybe.
Yeah, I think he would be an excellent speaker if you're looking for specific suggestions for specific speakers.
Maybe, yeah, let's switch to
Sorry.
particular, no, that's good. Particular people, if you have
Before that,
suggestions.
you just want to ask if everybody, is there
Yeah,
any
yeah.
other suggestions? Is there any other suggestions? Now is the time for topics.
I guess I have one last suggestion, which I'm not sure if we could do an entire meeting on this, but there's this idea of Mach's principle, which I thought is interesting. Like I've heard a lot of people say Mach's principle is like one of the first thing, like Newton's bucket, which is sort of an extension of the Mach's principle, is one of the extensions that you could, I guess, one of the first evidence for that Newtonian physics fails and that you need something like GR. I've heard other people claim that that's not necessarily the case and that it's more complicated than that.
So Dennis Lincoln and Harvey Brown have a paper on how Mach's principle changes like many times during the course of Einstein looking into it. I think Jaco knows a lot about it as well. They're looking for potential things.
Names.
Yeah. If there are any particular folks you'd like to see invited, please feel free to take voice now. And
Maybe I should have asked this earlier, but like, what is the general idea of this? I thought it was maybe. I've done it a couple times, but I feel like I'm maybe not aware of the history of it.
I think maybe Peter should fill in on this, but the general idea is foundational issues, but we're under now the HPC of the NGHT. So that's kind of in the background as well.
Yeah, but I do want to stress that the HPC role within NGHT doesn't have to cover everything. We also have a wider remit to the BHI's overall interdisciplinary concern with black holes. I think we do want to focus on black holes insofar as possible, rather than general astrophysics or foundations of quantum mechanics. I mean, there are other seminars that address those questions.
Okay, thanks, that's helpful.
Okay, this is the last one, I promise. I think that, okay, so there's another one that I think is interesting, which is when there's this statement of the event horizon versus apparent horizon. And the event horizon and apparent horizon only really coincides for specific space times and for specific observers. And I think it's somewhat interesting to like you can't really observe the event horizon. It's a global object. What you can observe is the apparent horizon. I think a curious thing to consider, like how different is the apparent horizon from the event horizon.
Yeah, this could technically be part of the series that Peter was suggesting on the horizon.
Yeah.
Yeah, we could deal with dynamical horizons, apparent horizons, yeah, event horizons, killing horizons, all these guys. Like potentially.
Yeah, actually, it's a nice suggestion. I've always wondered, there's this fireball or firewall that people talk about. Which horizon is it located at? I would have thought it should be the apparent horizon because that's what the local physics knows about. But I think to solve the various paradoxes, it should be at the event horizon, right? Which is teleological and all that stuff. So at least I have not heard a clear statement on exactly where this firewall forms. So if we are ever going to have a firewall-like discussion, this could also be part of that. Or maybe somebody knows the answer.
Yeah, that's a good suggestion. We'll add it to that.
And I noted down Lenny Susskind as well.
Okay. So I think for further topics, suggestions, you can email us.
Yeah.
And now let's switch to speakers specifically. So you suggested Alex Math here. I didn't catch the names of the next set of how math friends will.
Well, so Dennis Lanepool
Okay.
and Harvey Brown have a paper on how the various math principles for the time in Einstein's mind. But I think Jaco also knows it. About stuff quite a bit.
Yeah, other suggestions for speakers that we should invite?
I think Peter mentioned David Kaiser earlier.
Yes. Yeah, we have that. Do you have any suggestions? I mean, I'm not putting you on the spot. I'm just asking in general.
So this can be any discipline or.
Yeah, black holes.
Yeah, sure.
Yeah.
Okay. I got them. I got them.
Yeah.
It's clear. Maybe, yeah. Okay, let me think about maybe some
No.
GR people
Okay.
to talk about different types of
Yeah.
horizons. Maybe some young folks could talk because it will be a review.
Okay, thanks, Yanesh.
Actually, maybe Osmond. He's finishing grad student at MIT. He's very good.
Osmond.
Focus that.
Okay, I will ask you for his name. I can't. I'm not going to try this, but I can't. I don't think I can.
No, it's from Norton.
Okay.
That's why.
John Norton is scheduled to come already in the fall, I think for a colloquium though.
Okay.
Who?
John Norton. But we can keep him in mind.
Charmaine already gave a talk. Frenchilism.
Sorry, who?
I don't know.
Sure,
I'll
and then-
look back.
No, I don't think so. Maybe at the HPC meeting, last year. Okay, maybe not.
Oh, I know we closed down on topic, sorry.
Mhm.
But since someone mentioned error correcting codes in the chat,
Mhm.
there's kind of this fascinating new line of research relating black holes to actual machine learning, but like quantum algorithms. I don't know if that's of interest to if people heard that it's too far away from.
Yeah, that could be interesting. Do you have a suggestion for a speaker as well?
Well, there's one person I know that came from what's the word? Not machine learning. Anyway,
Yeah,
some like formal information theoretic point of view, and is now learning about black holes.
Okay.
She's very good. She's young though.
Okay.
I don't know if that's
So that should be fine.
Lisa Yang.
Okay.
Eric is mentioning Gordon Bellows.
For mock principle stuff. Okay, got it. Thank you.
Did Manus Visser already give a talk?
I can try.
He's Is this you saying goodbye?
Hey, no. I actually wanted to say something relevant for a change. So I just it's sorry, I'm outside and it's like some kind of construction site nearby. I just want to say that like kind of at the moment we're kind of jumped into the idea of kind of like running this as a sort of standard seminar series with speaker per session or something like this. And I just want to say that sometimes it's fun to experiment with the format. It's a bit harder, but it can work quite well and fun, like if we do debates or stuff like this, and I think the idea of like a debate or a panel kind of like ties with some of the things we discussed earlier on. And so I just want to say that like there are all of those formats and which are maybe like not the default format, but now we're kind of like jumped into the default one. And of course it's a good format, but it's also fun to kind of break out of it for a moment. Or every now and then, I guess. I also do remember that like ages ago, because I guess I can't now as a Stone Age person, especially with this construction going on here. We used to have this series where we didn't have a speaker, but someone kind of like was presenting a paper or a topic. I do remember that Ramesh gave super cool series of presentations, and Firas Azar was also doing this. And so that maybe sort of these sessions were in like a pre-read format, and I got quite a lot out of them. So sort of like pre-read, but an assigned presenter, which I think is less kind of committing for a presenter than a standard talk. At least some people may feel that way. I would feel that way. So I just wanted to point out that we also have all of these options that we could kind of explore to some extent. Yeah, that's it. Thanks.
I really like the idea of different kinds of presentation formats. If there are any particular topics that you think would be well suited to that, also feel free to let us know. Like the Horizon seems like it's well suited towards something like that, but
yeah, like Horizon would be perfect for this, I think. Yeah. And then ideally we could have like physics, math, philosophy person or some other mixture of this. So we would kind of like order presentations on a specific topic. And that I think is always super fun to sort of like force people to talk about exactly what we want to hear, rather what it is that they happen to work on at the moment.
Okay, yeah.
So Eric, are you thinking about mass, angular momentum, that sort of stuff, or in your comment here?
Yeah, that's only one example. Other issues, like a lot of holographic ideas and arguments depend very sensitively on how one treats asymptotic structure. Even observationally, the way that we model gravitational radiation in LIGO depends really quite sensitively on how one treats asymptotic structure. So it really does ramify. This issue really does ramify into all aspects of black hole physics. And as I say, there isn't even agreement on how one should. There's mostly agreement on how one should treat null infinity. There still isn't even agreement on how one should treat space-like infinity, spatial infinity.
This is quite interesting because like recently I think there's been work done on how to define and treat gravitational radiation and cosmological constant spacetimes. And yeah, there's interesting work there where you have to actually set up some sort of pseudo horizon, pseudo null infinity sort of thing just away from the boundary, and then you describe your gravitational radiation on that hypersurface. So that could be interesting as well to hear about, like how you're doing things, how you're defining gravitational radiation and non-flat spacetimes. Yeah.
Cool. Great. I guess if anybody also knows folks who will be around in the area at various points, feel free to let us know folks that would be like good to hear speak so that we can invite them in person. Like I have a list of folks in the UK from Jacob, and like if any of these folks happen to be around at a relevant time, as an example. So he suggests James Reed, Brian Roberts, Ollie Pooley, Jeremy Butterfield, Aaron K. Gomes, William Wolfe, and then beyond the UK, Neil Flynn. If you know of like any of these, or other people, these are all philosophy people, but if you know of any of these people are like visiting, let us know.
Oh, Will Wolf is from the US, so I guess.
Yeah, he's working with James Reed, but was in the US. Or it still is.
Oh, yeah, I mean, he's doing speech theater now, but I mentioned out of term time you guys.
Yeah, I think we have a few slots in November that we have open for now. So yeah, we'd be happy to invite people for this for the seminar in November. Yeah.
Artificial black holes.
Yeah, so feel free to follow up on email if there's anything that you think of later. But other than that, Maria. Okay. Eric,
For what topic?
yeah.
I mean, she's great, but
Biography of Interest and Change.
that's, yeah.
Okay. Thank you all so much for your ideas, your thoughts, and your suggestions. We will try to wrangle up some speakers for the next semester.
Thank you.
Goodbye.